Hello and welcome to a screencast about recognizing linear functions. The definition here of function f is linear provided that its average rate of change is constant on every choice of interval in its domain. So no matter what you pick for the domain or for the interval on the domain, that average rate of change will be constant. So quick refresh here of the average rate of change definition. So that is for any inputs a and b for which a does not equal b. So a and b have to be different, the endpoints. It follows that f of b minus f of a all divided by b minus a, so this is our average rate of change formula, equals m for some fixed constant m, which we all know is also called the slope. All right, an example. Is the given function linear? How do you know? So the first part of this question, you can probably use your gut. Does it look like it's linear? I don't know. I see some straight parts to it, but I also see some curviness to it. So my gut instinct would say no. But the more important part is, how do you know? So we have to go back to our definition that we just talked about. So let's pick an interval. And this is kind of arbitrary, so let's try to pick something that's got some decent points to it. So I'm going to use this y-intercept because that's always usually a nice point to work with. And then it also looks like there's a nice point here, and that looks like it's got the coordinates 1, 2, and this point up here has the coordinates 0, 4. Okay, so that means my a is 0 and my b is 1, because those are then the input values of the particular interval. Okay, so f of b minus f of a, so that would be, how about 4 minus 2 divided by 0 minus 1, so that's going to give me 2 over negative 1, so that's negative 2. Okay, so that means if I pick another interval, and I can use one of these points again if I want to, or I can pick a different chunk. It just depends on if we can find how many more nice points we could find. So it also looks like this one's a pretty nice point. So that's the point 2, 1. And I think that's probably about it. So let's go ahead and leave a as 0, but this time let's do b as 2. Okay, so then the first time I did the average rate of change between these 2 points, and the second time I'm going to do the average rate of change then between these 2 points. Okay, and if it's linear, what do we expect? We expect to get negative 2 again. So let's see if that happens. All right, so f of b minus f of a, so I'll do 4 minus 1 divided by 0 minus 2. I'm going to get a 3 over negative 2, which is definitely not equal to negative 2. Okay, so then I could definitely say this is not linear. Okay, so my gut was right, but you definitely need to make sure that you check this kind of stuff, only because sometimes your gut may not be correct. Or we might be giving you something really funky. All right, just one more just to make sure we kind of get the gist of this. So is the given function linear? How do you know? Oh look, I've got some similar points I can pick. So this time I'll again go with my y-intercept because I really like using that point. So let's use the y-intercept. Oh, and how about the x-intercept too? Just to be sassy, I guess. All right, so we've got those 2 points. So this time my a is 0 and my b is 8. So if I do f of b minus f of a, or I guess I'm constantly doing f of a minus f of b, sorry. But remember, the order doesn't matter as long as the numerator and denominator order matches. Okay, so I'm going to do 4 minus 0 divided by 0 minus 8, so that gives me 4 over negative 8, negative half. Okay, this I definitely see a lot more nice points on, so let's pick another set. This one looks pretty nice. So that's the point 2, 3, and this one looks pretty nice. That's the point 4, 2. So again, if this is linear, which my gut's telling me it is, then when I do my average rate of change again, then I should get the same thing as negative up here that we got was negative 1/2. So for this one, my a is 2, my b is 4. So then I'm going to do 3 minus 2 over 2 minus 4, and I get 1 over negative 2, but that's the same thing as negative 1/2. Okay, so yes, It is linear. So linear functions are something you've probably dealt with a lot in the past, but we're just going to make it take it to a little different level in this class. So I hope this video helped.